So we're going to present our project, which is an autonomous mobile surveillance system. So this project gets from the problematic that currently there are a lot of affairs on homes during the night. There is a growing threat with a constant increase in reporting incidents. This situation negatively impacts the safety of citizens and the economy, worsening each day due to the insufficient response from authorities and the lack of resources and evidence to identify the perpetrators. Um, so we try to create an autonomous surveillance system capable of moving freely within this specific area while detecting sounds and potential intruders. Now we have here our action diagram, which simplifies what I currently said in the last slide. We have an exploration stage, then we move up to the navigation stage, and in there we can move on to a manual stage, or either alert one for a sound detection or alert two for a person detection.
The most important process for the execution of the rover is control, computer vision, SLAM, navigation, and sensor data. For the control algorithm, we use a route planning. The route planning use a PRM that is used for point generation, and then we use the Dijkstra algorithm that is employed to find the most optimal route from a starting point to an ending point. From the execution, an algorithm was designed to enable the possible to advance and turning in a direction with the goal of covering the largest possible area and avoiding obstacles. Proportional control was used to ensure it follows trajectories. Additionally, sensor readings are obtained so that the robot can adjust it is the trajectory if encounter an obstacle that slightly obstruct its path. If it cannot advance, it enters reactive navigation mode and then returns to trajectory control afterward.
Now, for computer vision, for the neural network section, a pre-trained convolutional neural network was used, specifically YOLO 8, to which a dataset with our image was loaded to detect people. With this CNN, we can perform real-time detection with high accuracy. Prediction: the image of frame is divided into regions, predicting bounding boxes and probabilities for each region. The bots are weighted based on the predict probabilities. Implementation and adjacent, it was converted to an ONNX format because this format allow us to perform detection within the JSON by optimizing performance. Now, for SLAM, the G-mapping algorithm was employed, which is based on SLAM techniques. Using data from a LiDAR sensor, it constructs on a map of the robot's environment. Data transformation. The points obtained by the LiDAR are transformed from the sensor frame of reference to coordinates that the algorithm can use to generate a coherent map of the environment. For the odometry integration, the odometry obtained through the wheels and colors of the robot is integrated with the LiDAR data. This additional information is crucial for determining the precise localization of the robot within the generated map. Kalman filter. For the implementation of the Kalman filter, it was applied to the position generated by the SLAM algorithm. The filter position resulting from the Kalman filter is used in route planning, trajectory control, and overall robot position management.
Well, for the navigation, for this part, we confine the robot within imaginary quadrants in order to explore all of the different places while not leaving spaces unexplored. In order to prevent the robot from leaving the quadrants, uh, some imaginary walls were put, and the distance between the robot and them is calculated in a way that it simulates the leader. The real lidar is used as well in order to detect either objects or walls, and the sensors that we implemented are used as well in order to dodge if they were not mapped. For the part of integrated sensors, as we mentioned earlier, we used some additional sensors in order to get different readings. The most important sensor was the sounds detecting sensor that allowed us to enter the state so that the puzzle bot can start to navigate between some of the quadrants. In order to implement all of the sensors, we used a PCB that was handmade in order to facilitate the connection between all of them. As we mentioned earlier, the sensors help us to detect possible intruders and to detect things that the lidar can see. Additionally, we use an ESP32 and a joystick in order to enter the manual mode.